So hello, my colleagues, and I hope everyone is well. So I received a question, an excellent question, and it says, I have a question about perfectly negatively correlated assets. Here is an example of table 8.7 and below is a relative picture. How can we determine the portfolio that portfolio is perfectly negatively correlated assets? Do we just assume portfolio X and Y is perfectly negatively correlated assets because of 0% standard deviation? Actually, well, it's more than that. That's part of it, but it's more than that. And basically, that will show you that it's risk free. Okay? So I'm going to use a different textbook that's got more detail on that whole topic. Okay? So let me bring up the textbook that I wanted to bring up. Okay, so this is my textbook from MBA 502, and this is called Corporate Finance, a little more advanced, by Burke and DiMarzio. Okay, so how do we determine perfectly negative correlation? So to find the risk of a portfolio, we need to know more than the risk and return of the component stocks. So that means more than the risk, more than the standard deviation, right? We need to know many things. We need to know the degree to which the stocks face common risks and their returns move together. In this section, we introduce two statistical measures, and this is the main ingredients, these two, of how you determine perfectly negative correlation. Okay? It's called covariance and correlation. Okay? So these go hand in hand and add to standard deviation to let you know how much how things are negatively and positively correlated. Okay, so let's start with covariance. Okay, covariance, and these are really statistical problems that I don't expect you to know all the math, but I just want to introduce it to you. Okay, because this is an excellent. This is the answer to an excellent question about negative and positive correlation. Covariance is the expected product of the deviations. And you know they always use the word expected of two returns from their means. Okay? So this is the expected product of the deviations of two returns from their means. The covariance between returns R1 and Ri and Rj is, and here's the equation for covariance. And all it is the expected return. And again, you see it's a product, right? This is multiplied here. The expected return of the return on I minus the mean of I times the expected return of Rj here times Rj. All right. So you got two means, one, two, and then you got two returns, right? So basically, you got the returns and how much it's going to deviate from its mean. Okay. So that is how it's defined. Now the question is basically, so this is the correlation between two returns here. So when estimating the covariance, so when estimating the covariance from historical data, we're going to use this formula. Okay, so there's two formulas. This is for future data. Okay, so this is data for two returns that we're basically assuming we know get the mean from in the future. And now here it is. Now you notice the word historical. Okay, this is historical. So the estimate of the covariance from historical data is shown this way. All right. So there's actually two equations. All right. So intuitively, if two stocks move together, and here's where the correlation comes in, their returns will tend to be above or below average at the same time, and the covariance will be positive. So this is the next test of, and this is what you need to, as we develop correlation. If the stocks move in opposite directions, one will tend to be above average and the other will be below average, and the covariance will be negative. Okay? Now, now we got onto the now we move on to the correlation. So we've done the covariance, okay? Now let's do the correlation. Both of these are very important with regard to stocks moving and whether they're negatively or positively correlated. When the sign of the covariance, while the sign of the covariance is easy to interpret, its magnitude is not. It will be larger if the stocks are more volatile and also have larger deviations from their expected returns, and it will be larger the more closely the stocks move in relation to each other. In order to control for the volatility of each stock and quantify the strength of the relationship between them, we can calculate the correlation between the two stocks. Okay? Defined as the covariance of the returns. Okay, so now this is where the covariance and correlation are coupled, divided by the standard deviation of each return. So you can clearly see, you'll notice we have correlation here, we have covariance, and the standard deviation, not just the standard deviation alone. All right? So the correlation between two stocks has the same sign as their covariance, so it has a similar interpretation. Dividing by the volatilities ensures that correlation is always between -1 and +1. Okay, so this is real important, which allows us to gauge the strength of the relationship between the two stocks. Okay, so you can see where the statistical mathematics comes in. As figure 11.1 shows, correlation is a barometer of the degree to which the returns share common risk. And here is what the question basically was based on, and tend to move together. So it's really all a function of correlation and the calculation of covariance, standard deviation, and correlation. The closer the correlation is to +1, the more the returns tend to move together as a result of common risk. When the correlation and thus the covariance equals 0, the returns are uncorrelated. Okay, that is, they have no tendency to move together or in opposition to one another. Independent risks are uncorrelated. Finally, the closer the correlation is to -1, the more the returns tend to move in opposite directions. Okay, so that's how that goes. Now here's a nice graph that shows that, right? And I think you might have something similar in your book, right? Perfectly negatively correlated is -1, and perfectly positively correlated is +1. So correlation measures how returns move in relation to each other. It is between +1 and -1. Independent risks have no tendency to move together and have zero correlation. All right, so something should be very obvious, and this is a nice example. The covariance and correlation of a stock with itself, okay? What are the covariance and the correlation of a stock's return with itself? Okay, so basically, let RS be the stock's return from the definition of the covariance. The covariance is just the variance of the stock with itself, right? Where the last equation follows from the definition of the variance. That is, the covariance of a stock with itself is simply its variance, okay? That should make sense, right? Now, the correlation is always 1, right? A stock is always going to be correlated with itself. That's 1. Where the last equation follows from the definition of the standard deviation, right? So that is, a stock's return is perfectly positively correlated with itself, right? It's going to move with itself in the same direction no matter what, as it always moves together with itself in synchrony, right? So these two items should be very obvious to you, right? All right, now Excel does a little silly thing with variance and covariance. They've changed it. So you got to be very careful using Excel with variance and correlation, covariance, to make sure because they've changed it over time. All right. So let me see if what I want to see if I can find here. All right, so let's compute the volatility. Let's go through this example, which is real nice of a two-stock volatility.
Computing the volatility of a two-stock portfolio. So we're going to use the information from table 12.3, and we're going to look at two different portfolios. One is of Apple and Microsoft, and the other is of Apple and Starbucks. So looking at the table, we see that Apple has a standard deviation of 41%, Microsoft 28%, and Starbucks 32%. So that's their volatility on their own. If you look at the formula for the variance of the portfolio, we need to know the weights, how much money we're going to put in each of the stocks, what proportion of our money we're going to put in them, their individual standard deviations, how risky are they on their own, and then we've got this third term that accounts for how they vary together, their correlation. So we'll need to know their correlation as well, and so we'll see that Apple's correlation with Microsoft is 0.48, and Apple's correlation with Starbucks is lower at 0.38. So now we've collected the information that we need, and we're ready to start calculating the variance on the way to calculating the standard deviation. And the portfolios are equal weighted, equal amounts. So we know our weights are going to be 50%. So if we plug everything in here, we've got 50% in Apple, and so then we put in the standard deviation of Apple, which we just figured out was 41%. And then we've got 50% in Microsoft. 28% is its standard deviation. Now we got to fill in our weights here, 50%, 50%. And then there's this correlation term, which accounts for how they move together, how much they move together. And so that's 0.48 in this case. Put in the standard deviations again of each one, 41% for Apple and 28% for Microsoft. And if you work out the math, you get 0.08918. Now remember, this is the variance, not the standard deviation. This is in units of percent squared, so we're going to then calculate the standard deviation by taking the square root of the variance and that comes out to be 0.299, which we can represent as 29.9%. So that's the standard deviation of the portfolio of Apple and Microsoft. If we go ahead and do the same math for the portfolio of Apple and Starbucks, we're going to go through the same thing. The weights don't change, and Apple's standard deviation is of course the same, but what's going to change is the Starbucks part. So first term is the same because that accounts for Apple. The second term is different because now we're dealing with Starbucks, and that has a volatility of 32%. So the third term will also be different because, first of all, they have a different correlation. They don't move quite as much together, which makes sense. Both Apple and Microsoft are in the tech space, so they have a higher correlation than Apple and Starbucks, which retails coffee. And so then we fill in their standard deviations here at the end, and we come out with 0.09255. And so when we do the standard deviation of this particular portfolio, we're going to get square root of 0.09255, which is 0.304, or 30.4%. So notice that these are extremely close together. Both are basically 30%. So the two portfolios are essentially equally volatile. And that's interesting because Starbucks is more volatile than Microsoft, right? So it's a riskier stock on its own, but we've put it in a portfolio with a stock that it's less correlated with. So you're getting more diversification when you put Apple and Starbucks together than when you're putting Apple and Microsoft together. And that additional diversification offsets the fact that Starbucks is actually a riskier stock. And you end up with portfolios that have basically the same amount of risk because of the offsetting effects of the diversification and the risk of the individual stocks that are going into them.
I showed you that example, and what I wanted to show you is we now have the tools basically to compute the variance of a portfolio for two stocks. So you saw that. So the variance of a two stock portfolio, okay? So we're talking about portfolios now, is simply this equation right here. They take this, right? And basically they simplify it. So here's how you get the variance, okay? And I believe he used that in the example we just saw. And again, the standard deviation is just the uh, square root of the variance, okay? So he goes to a nice example here. And there's another one here. You can stop here and go through this. If you have any questions, just go through that. All right, so this was what we just watched, okay? Okay, so now I want to just show you the volatility of a large portfolio. Okay, so the covariance of a large portfolio will just be this equation here with more than two stocks. And it would basically be the sum of the percentages, right? The weights times each covariance of each stock within the portfolio. So this equation indicates that the variance of a portfolio is equal to the weighted average covariance of each stock with the portfolio. And see, this is what's determining whether or not there's a correlation. This expression reveals that the risk of a portfolio depends on how each stock's return moves in relation to it. Okay? So basically, they reduced that equation even further right here. Okay? So the variance of a portfolio is equal to the sum of the covariances, okay, of the returns of all pairs of stocks in the portfolio multiplied by each of their weights. So you could do this in Excel, right? You could set up an Excel equation. That is the overall variability of the portfolio depends on the total co-movement of the stocks within it. Okay, so here's the variance of an equally weighted portfolio. Okay, if you have stocks that have equal weights in your portfolio, let's say there's five and they're each like 20%. So you would just take the number of stocks, all right, and basically times the average variance of the individual stocks, and then plus 1 minus n, the average covariance between the stocks. Okay, so that gives you, if you have n stocks and they're equally weighted. All right. All right. So you'll notice here this is a good graph. Here's your portfolio volatility. And as you go across, as you increase the number of stocks, you'll notice the diversifiable risk reduces because you have more stocks, right? But the correlated market risk you can't get rid of, right? That's something that's correlated, which is a function of the correlation coefficient. That's correlated, and for each stock, and you can't get rid of that, okay? But you'll notice how this decreases as you add more stocks. So the volatility declines as the number of stocks in the portfolio increases. Even in a large portfolio, however, the market risk remains. So you're always going to get market risk. All right, so I will, so here's the volatility. This is a nice example. What is the volatility of an equally weighted average of n independent identical risks? Okay. If risks are independent, they are uncorrelated. So right away, if they're uncorrelated, that means the correlation coefficient is what? It should be zero, right? And their covariance, right, becomes zero, right? So the volatility of an equally weighted portfolio of the risks are, and this is what it becomes, right? Okay, so all right, so I think I will cut off there. If you have any other questions, I don't want to go into general portfolios because this was just an introduction to a question that was asked, okay? So I'll provide more detail if you'd like. All right, I hope this helps.